Hi everyone, I'm going to demonstrate in this video how to calculate the mean, the variance and the standard deviation for a discrete random variable. So the problem that I've set up here is we have a variable, discrete variable that ranges in value from 12 to 17, and the probability of each of these values is listed here in the table. Now remember, if this is a proper distribution, then each of these values will be between 0 and 1, nothing less than 0, nothing more than 1, and they will all add up to equal 1 because these are the only outcomes. So first of all, to calculate the mean, sometimes we say that the mean is the same as the expected value of x. Then we would go the sum, so we need a capital sigma, and we have the score x multiplied by the probability of each of those scores, which is great. Now how do we go about doing that? Well, we would, here we go, we'd have 12 times 0.1, and then we would add 13 times 0.1, and this is rapidly going to get far too tedious to type, so I'm just going to go continuation, and then we'll finish with the final entry, 17 times 0. Oopsie, hit the space bar then, 0.1, and so we're showing our working, and it's a little bit summarised. Now, how am I going to put this into my calculator? That's the main purpose of this video. Well, I don't really want to be typing all of that, so I'm going to use the statistics app. That's that one there. And the statistics app allows me to store lists of data. So I'll store the scores, 12, 13, 14, 15, in list number 1. And I'll store the probabilities, 0.1, 0.1, 0.3, 0.2, 0.2, and 0.1. Hope I got them all right. I'll store them in list 2. There they are. Now they'll remain in the memory, and I can refer to them by these headings, list 1, list 2, even when I press the menu key and go back to the usual run matrix screen where I perform calculations. So what am I really trying to do here? I'm trying to multiply the value in list 1 times the value in list 2 for all of them, and then add up each of those. So press the options key. We have a menu here of choices for lists. Move to the next menu, move to the next one again, and there's the one I want, sum. I want the sum of the following. I want list 1 multiplied by list 2. So that takes care of the products, and this takes care of the sigma notation, adding up all of the results. And I get the answer 14.6. So I'll just put that here in my working. 14.6 is, that's the mean, the expected value. If we had a very large sample, say we did this experiment where we ran this experiment 1,000 times, and we took a note of all the different values that we collected, and then we did the mean of those values, we would expect it to be very close to 14.6. The bigger the sample size, the closer it would be to expectation. There it is. It's really a weighted mean. Now, what about the variance? Well, we have a formula for the variance of the variable x. Sorry, that's the capital variable. Right, here we go. Now, the formula for the variance is the sum of sigma, and this time it is x squared times the probability of x, and after we do that sum we subtract the square of the mean. What's that going to look like? Well, it's going to be x squared is 12 squared times 0.1, the probability, plus plus The last one is 17 squared times the probability for that one was also 0.1. And once we've added all of those up, then we subtract 14.6 squared just the once at the end. The sigma notation here only applies to the x squared times probability of x. The minus mu squared, the minus the mean, is after the summation. So that's lovely. Now, how will we get our calculator to do this one for us? Well, again, it's a sum, so I'll press sum. This time I need to square list number 1. So I'll need an extra pair of extra pair of brackets for that one. So list 1 enclosed in brackets to the power of 2. That's this x squared part. Remember the scores were stored in list 1, multiplied by list 2. Close the brackets for the summation, subtract 14.6 squared. Now, because that was the previous operation, I can just recall the answer, 14.6 squared, and it gives me a variance of 2.04. There it is, 2.04. Isn't that lovely? That's the variance. And finally, we want the standard deviation. And the standard deviation equals the square root of the variance. Oh, helps if I spell, doesn't it? Try that again, the variance. Now, why didn't all of that appear underneath my lovely square? Ah, that's what went wrong. Formatting's a little bit funny sometimes. So it's, this one's child's play really. It's, the variance was 2.04. And here we go, I want the square root of the previous answer. Oh, that's nice. Go into decimals, 1.43 approximately. Oh, what happened to my working? I'll just do that again. What did we say? 1.43. There you go. That's how you calculate the mean, also known as expected value, the variance, and the standard deviation for our distribution. So we would expect, if we did this experiment a very large number of times, kept note of what the different scores between 12 and 17 were that we collected, we would expect a mean value of 14.6, and we would expect a standard deviation of about 1.43. The bigger the sample size, the closer we would be to those. The important bit about this video is how to store the data in lists to simplify your calculations the way I showed here.